reason why we share the ground is our common reference. Now, if I've got two different power supplies, they might have a slightly varied ground reference to each other. And what will happen is the current will then start to go through to that way because there's a slight variation in the zero reference. So what happens is you get ground loops. And what happens is you get flickering and all weird behaviour happening. So that's why it's imperative to have the grounds connected between the strips, right? And regardless, always grounds get connected between all pixels, because that way you're stopping from having, this might have 0.1 of a lot more difference than this one, so they're not balanced. So current is then going to start flowing ways where it shouldn't flow, and affects the data. So
you run a bit of cable between the ground on one power supply to the ground on the other power supply?
No, don't have to do that.
So you're only talking about the strip, not the extra power supply.
Where you do your connection, your common connection, is here. See how these connected? The ground's connected there, and the ground's connected there. It's connected through, if these are two different power supplies, alright, the plus V is separate, but the ground has been kept common because they're connected between the two.
So you're connecting all the grounds together there.
Yep. So they're connected common through here. So that's why it's important to have the commons connected through here, as opposed to, you don't have to do it back at the power supply. If you do it back at the power supply, what happens too is you might have two separate lengths of run. Now those two separate lengths of run are going to have different resistance values now, because with cable length you get different resistance values. If you've just got it connected at the power supply, what you've then created is a situation where you've got two different references again because of the resistance, the different resistances, and that's why you always connect here. It doesn't have to be done back at the power supply; it has to be done here, because then it's right here. It's common now. It's sharing exactly between that pixel and that pixel. The reference is the same. So that's
you're just basically continuing the data, the clock, and the negative as if it's one long strip.
Yep. Just keep going along.
So if you wanted to, you could put the power supply on the actual thing and just bridge it out to 3 points.
You can have a run of. I mean, an example. How do you think that when we looked at the Harbour Bridge? There's no way they can't have they have to have multiple power supplies along the line. Right? There's no way over that distance you could actually create from one power source. So they would have multiple power supplies going along, and what we'd be doing is, and this is why all the strings and strips come from RAID. They usually come like that. They usually come with a second black wire. All right, I know a few of you guys have bought the strip and found a second black wire. Well, that second black wire is for the injection. Right? So you can still connect it to the next pixel, but then you can bring in your injection. All right, your negative injection and your plus injection, because you're not connecting between the two pluses together. So you just pull off your plus, pull off your negative, connect your injection, connect the negative between those two, and connect the data between those two, and then you've got your injection done between two different separate power supplies. If you've got the same power supply, it doesn't matter if you've got the positive connected together. It's only if you're using separate power supplies. And so usually you'd need that, say, if you're doing the gutter on your house, and you've got one long run on your house, by the time you get to the end of your house, and if you're using 5-volt strip, there's no way, regardless of how thick cable you're going to use, that you're not going to get voltage drop down the other end. So you have to use a separate power supply. And that's how you do it. You basically you keep the earth common, and you keep the data together, and you keep the positive separate.
Well, the reason you don't join the two positives together is because one power supply might be at 4.8 volts and one might be at 5.2. And the different, and if you connect them together, the 5.2 will be taking all of the current, and the 4.8 won't.
Because they're not designed for load sharing.
That's right.
So instead of having like your two smaller power supplies, and say for example you wanted to go over some distance, right? Say 20 metres, you could have one major big power supply, say in the middle, and
you could
supply that.
But again,
so like
depending on the distance, you're going to having big power supply can be risky because two things. If your power supply fails, you've lost your whole show. I'm always believe in having lots of smaller power supplies and keeping one or two spare, because if you do lose part of it, you only lost part of your show at the moment, and you can quickly repair it the next day by replacing the power supply. If you have one big major power supply, throwing all your eggs in one basket, and then you've got the voltage drop issues to deal with, because especially if it's 5 volt, you know, to go from a run from, you saw that is only just run to that there. So that's run from there to there, created that much voltage drop with 5 volt. So either I use thicker cables, more cables, and it's going to start costing you money on more cabling and things like that. So it then works out better than to say, well, I might as well buy smaller power supplies and distribute those power supplies further down along the line.
Technically, you'd have a nest somewhere further down.
Well,
Power
what you do is you
supplies.
try to keep the power supplies close to where you're injecting.
Yep.
Right? You want to try and keep the run between the power supply and where you're injecting as close as possible. Because the closer you do, the less resistance you have. It means the higher you can utilise that cable as far as current draw is concerned.
A little bit out of even my price range. The lights affects it.
Well, yeah, the spacing affects it. Good example is the modules. The modules, all the modules are. Who had the modules before those?
The
Rectangular
series
modules.
amateur slash businesses.
You're a government for a second.
Small business setups.
Right? This will give you a great example, because all these are is a strip section. That's all these are. All these are, if you look at that strip over there, all that is just one section, isn't it? That's all it is. But you know what? You can connect 50 of that, you can have 50 sections together without voltage drop.
Yep.
You can only have 20 of these before you start seeing voltage drop. Because the cable. So the cable is then creating extra resistance. All right? So that's why these are only sold in lengths of 20, and strip is sold in lengths of 5 metres or 50 sections. All right?
Again, depending on how you're using those, there's ways around having the power go along the bottom of your candy canes rather than up through the cable
Yes.
and then down to the next one, which is
Yeah.
makes sense.
There's ways to overcome voltage drop many different ways.
Yep.
But, you know,
Because I'm running 120 of those, and there's one power injection point halfway along.
yep.
But the power runs along the bottom of every item, so it's only the cable probably here to the corner long. Each item comes off that cable. Yes, up here there's a voltage drop, because
But your
again they're
cable-
12 volts.
But the cable you're using
Yep.
is a pretty chunky cable, because it's going to take the current of all that load.
That's correct. That's correct. I'm using 6 core for the power injection and doubling or trebling up on the power on each one. So halfway along, there's 3 cores of cable for positive, 3 cores for negative. So yes, it does work really well, but because you've only got a stub of 10 or 15, I think is the longest item. Yeah, okay, there is a voltage drop. Again, because they're 12 volts, you don't notice it as much.
I mean, I've done that exactly with my roof.
Yep.
I use these modules on my roof. And what I've done is, instead of just going zigzag like that, right, by the time I got to the end, I was getting voltage drop.
Oh yeah.
So what I did is, I just loop wire like that. So now I don't get the voltage drop.
Yeah, it's just the way you connect them up. It's not perfect, but there's ways
I mean,
around
the
most
power
of the
still
issues.
goes this way, but I've just injected the power to the other end, so it's just...
So really the longest set of pictures, what are they? 10 each way?
Got on a different device now.
Yeah, running out of data. Had to switch devices, so I've got more data.
Yeah, so that's basic explanation of voltage drop. But, I don't think you sort of realise how much of a depth voltage drop you have on that. I pull that out and we instantly pick.
And I had an issue with one item last year, the voltage drop.
Yep.
Really amazing.
When you look at it this way, similar cable. Okay, so similar cable. So when you look at the voltage and the resistance, and we say, okay, we look at exactly the same current between 5 volt and 12 volt, all right? The amount of voltage might end up being, say, 1.2 volt.
Hang on, was that the camera? Or is it up this corner?
It's up this corner.
Yeah, that's really big.
Yeah, that's LSP. It does that. Smart. Smart. It does that. And it's funny, if you save it, exit the program, come back in, it won't do it.
Why do you
Yeah,
want?
that's LSP doing it.
Oh,
It's
flickering.
actually got a couple of different effects doing it at once, and it just plays up when you do that. If you save it, exit it, come back in, it's usually not a problem. It's just the way it does it. Yes, there's a stuck green one down there. It disappears.
Biggest problem I've had with that LSP, especially last year, is the it lags between the song and the actual lights.
Didn't have that problem, and I was pushing
When I was
10, 12 frames a second out for 19,000 channels. But some things I had to back right off to about 8 frames, 7 frames a second. If I threw in effects on everything, which I don't agree with the way Eddie was saying this is how to program. He wasn't saying this is how to program. What he was saying is this is what you can do to program. 50% or more of my my show is done by hand.
Yeah.
The other 50% is
Yeah, well, if I was to do it like that, I was doing effects all the way along. That was my problem.
Doesn't work that way.
Doesn't work at all. Yeah. You can only you can throw an effect here and there for short periods of
I use effects on
time.
the Megatrees. I used effects on the house. I did full colour sweeps, but I found I could only do about a 5-second full colour sweep. If I did an 8-second one,
And then you got to have a
stop.
Yeah.
And then go, oh, I'll catch up, and then everything would just be out for ages. If I made it 5 seconds, wasn't a problem.
Yeah.
Yeah, you try pushing 19,500 channels, doing that sort of effects. The CPU on the PC at home, 100% constantly, and it's an i5 Ivy Bridge. Yeah, it was really being pushed. So therefore, I tended to do a bit of sequencing as well as LSPs. Hopefully, this should fix it. But hopefully, this year, with the work that they've been doing, that shouldn't be an issue.